A major hurricane has been developing in the central Atlantic, and meteorologists are trying to figure out, will the storm strengthen, will it weaken, and where's the storm going to go? This is a classic scenario that meteorologists are faced with during tropical weather season in the Atlantic basin. And today on Weatherwise, I'm going to discuss hurricane forecasting and why it seems like these storms have a mind of their own. Hello, welcome to Weatherwise. I'm meteorologist Nathan Scott. We are going to be talking about hurricane forecasting and why storms go in different directions. There's a reason behind the madness. First of all, let's talk about why tropical storms and hurricanes develop in the first place. You need three things in place. Take a look at the graphic. Tropical forecasting. Three ingredients. You need warm ocean temperatures. Temperatures must be at least 80 degrees for storms to come together and develop into a tropical storm or a hurricane. But also, it's not just about the temperature right at the surface of the water, it's also how deep that warm water goes that can really influence the power that a storm can tap into. Along with that, loop currents. I'm sure you've heard about that infamous loop current in the Gulf. We'll talk more about that. Dry air and moisture levels. A hurricane can't form if there's too much dry air. We'll discuss the reason behind that case. And also wind shear. Wind shear is one of the worst enemies of tropical systems. It tears the storms apart. So let's talk about, first of all, the ocean temperature. These are the current sea surface temperatures as of September 2nd. And what you see here is the color that represents anything above 80 degrees or 80 degrees and above. So that goes all the way up into the northern Atlantic, as far north as almost New Jersey. But even the Chesapeake Bay of Maryland has temperatures 80 or higher. But look at the purple areas, and that's where the sea surface temperature is more like 85, 86, 87 degrees. So if there's something that's trying to develop, it's got plenty of warm ocean water to feed off of. Another bit of information we look at is the ocean temperature anomalies. We know it gets warm in the Gulf this time of year. It's not unusual for the Gulf to get up to 83, 84, 85 degrees. But when we take a look at the anomalies within the ocean temperatures, you see this pocket of some colder temperatures. It's not much. It's probably about a degree or two. But you know why this is the case? Well, that's from the upwelling that's still in place, what Aaron left. That happened just a couple weeks ago. So you see Aaron was a Cat 5 around this part pretty close to the Bahamas, and then it left that colder pool of ocean temperatures with the track, and you see there even just off the coast of New England. Meanwhile, we do have warmer than average temperatures in the Gulf and also out into the central Atlantic pretty close to Bermuda. The temperature of how far that warm temperature goes depth-wise is known as the ocean heat content. So when we take a look at this, we're not just looking at, okay, temperatures are 80 degrees or higher right at the surface of the water, but as you get deeper and deeper, then you start tapping into, well, the depth of how warm the ocean temperature stretches down. And we have a big area right here, so we've got a lot of fuel. According to this latest information, if something tries to develop off the coast of the Yucatan and goes between the Yucatan and Cuba, they're going to have a good opportunity to develop very quickly. And then right about here is where you have that classic loop current. And that's what happened with Katrina. Katrina was a Category 1, and then it hit that loop current and it just exploded into a Category 5 with about 18, 24-hour time frame. And then it made its way, of course, into Louisiana. But look at the ocean heat content. It does extend all the way right along the Gulf Stream, because the ocean current, of course, in this part of the world, you're bringing in that warm tropical air right along the eastern seaboard. So that is one thing we're looking at, and that ocean heat content goes all the way out into the eastern Atlantic for the most part, just off the west coast of Africa. So all this area is primed, at least for the ocean temperatures, to have tropical development. But that's only one factor that we're considering. Another factor is, of course, the moisture levels. And something that always happens this time of year, and it's good, is the Saharan dust. We discussed Saharan dust in an earlier episode of Weatherwise. You can look for that, of course, through YouTube or also here on THV 11 Plus. I talked all about Saharan dust and why Saharan dust develops in the first place. But when we break it down now, as that dust blows off from the Sahara and makes its way from the east to the west, that is a huge influence in what happens with the ocean temperature. And that's because the dust can be so thick that the sunlight has a harder time to penetrate through that layer of dust, and therefore that can actually lower the ocean temperature. So there you see the Saharan dust. It not only brings dry air, which is going to basically hurt the development of tropical systems, but on top of that, you also have the ocean temperature becoming cooler because of that layer of dust. Your ocean temperature may drop from, say, 80 degrees down to 78. And once again, you have to have 80-degree temperatures to support tropical development. Dry air, you can't have dry air. And you see this all the time. Saharan dust can be a huge factor. You can have a monster, a Category 5 storm, which is, first of all, unstable. It usually doesn't last more than 24 hours. It's Cat 5. But if you have dry air that comes in, say from Saharan dust or also from other parts of the world, and it gets into that tropical cyclone, it can just weaken it in a rapid fashion. So you can go from a Category 5 easily down to a Category 2 with a matter of 12 to 24 hours. Another thing that really devastates tropical cyclones is wind shear. And wind shear is when you have an area of high pressure and an area of low pressure, that pressure gradient that you have winds develop in the first place. Well, when you have wind shear at different layers in the atmosphere, it can basically disrupt the whole machine of the hurricane, because with a hurricane, you've got a surface low pressure developing and a upper level high pressure way up into the atmosphere. And of course, this is evacuating all that air. And this is all working together. You have one little kink that moves in, say wind shear, look what happens. Those storm clouds, it disrupts the whole machine. Those storm clouds start to tilt and basically get shifted, and then you lose that whole warm air process that fuels this machine, and also these storms can be ripped apart by wind shear. So therefore, the storm can weaken very quickly, and that's always good news, is what we're looking for. But sometimes wind shear happens that you don't really expect, and that can, of course, change the forecast from the National Hurricane Center, thinking, oh, let's just be a Category 3, wind shear kicks in. Well, it was a Category 1. Of course, that's good news for those people impacted, but the forecast may not verify as expected. So those are the three ingredients when it comes to tropical forecasting on whether a storm will strengthen or whether it will weaken. Next, we'll discuss why storms seem like they just go in any direction, why they curve out to the Atlantic, or why did they go into the Gulf of Mexico. That's all because there are several players on the board, and tropical systems are basically, if you think about, a cork in a stream. If you throw a cork in a stream, there's no way that you can really predict exactly where that cork is going to go in a short amount of time. Well, that's the atmosphere. But fortunately, with numerical weather models, we do have an idea of where these different players are, and we'll talk more about that coming up. If you have a good memory, you probably remember Hurricane Dorian. This was a monster storm that impacted, say, the Great Abaco part of the Bahamas, but the forecast details on this system was very tricky, and the track, it was very difficult to nail down. This is from the National Hurricane Center, the archives. There you see August 24th, 2019. There's where the storm is located, and it wasn't formed just yet, but it quickly was supposed to expect it to be a tropical storm and then a hurricane as it approached the Lesser Antilles, and then as it made its way towards Puerto Rico, is expected to become a hurricane. So just a refresher, if you missed the last WeatherWise episode, this cone area, the solid area, that's a 1 to 3 day forecast, and then the checkered area or speckled area, that is a 4 to 5 day forecast. The center of this storm, as long as it is in between these two lines, the forecast verifies. I'm going to put this into motion. Let's take this full and watch what happens as we go day by day and how that track changes. You see, it's expected to make its way towards Puerto Rico, then shifts its way into the Dominican Republic. Then it's aimed at Florida, and it's aimed as a major hurricane for Florida. But watch what happens with that turn. It makes its way towards the Bahamas, and then it hooks back over to the north and over to the right. So it was knocking at the doorstep off the east coast of Florida. And it was a scary situation because you had a massive hurricane that just devastated a part of the Bahamas, and then it was making its way towards Florida. Fortunately, it curved back out to sea. We knew it was going to curve back out to sea. The meteorologists for the National Hurricane Center expected that because they were watching what was happening in the upper parts of the atmosphere and also the other surface features. So if we didn't know what was going on at the surface or in the upper parts of the atmosphere, you would have said 100% that storm is going to slam into the coast of Florida, and it was only probably about 50 to 100 miles away from making landfall. But fortunately, there you see, it made its way back out to sea. So let's go over to Max now, because we're just going to do some scenarios here with how a hurricane operates. So when we take a look at Max, if we can pull that up, Perry, thank you. You typically have a huge area of high pressure situated over the Atlantic. It's known as the Bermuda High. And this moves east and west from time to time. When you have a tropical system develop off the coast of West Africa, it makes its way pretty much west or east to west around this area of high pressure, because airflow around high pressure is clockwise. So that keeps the system pretty much along the southern route. Now, if the system decides to form a little bit farther to the north, the odds of that will keep it out to sea if it's at a certain latitude. I don't know exactly what latitude, I have to look that up. But right now, this is the scenario. We have a hurricane or tropical storm, whatever you want to say. It's going to make its way along the edge of this subtropical ridge. And what's going to happen with this? Well, let's just say the high pressure continues to also move to the west. So therefore, it's going to keep that system down through the Lesser Antilles, through the Greater Antilles, and then it may push it into the Gulf and then over to Mexico or maybe Texas. So this high pressure is protecting the East Coast, and it's most likely protecting Florida. Unfortunately, it's aimed in the Gulf in this scenario. Scenario number 2, there's our high pressure, there's our tropical system. What's going to happen with this? Well, let's say the high backs off to the east. So therefore, the storm system will ride along the ridge just like a Ferris wheel, riding right around the edge of that ridge, and that will keep it well out to sea. We see that a lot. It's kind of what happened with Aaron. You know, it got pretty close to the U.S. mainland, and then it made its way back out to sea. Scenario number 3. So here we have the high pressure. There's the next tropical system. What will happen with this? So when we take a look at this one, the high pressure is not moving much at all, so it's just going to follow right along with that. And then we have a scenario where it hits Florida or it hits the southeast coast. This is just one player, though, on the board. And you see how much influence that one player has. And that's a big factor, is that subtropical ridge. But of course, that's not a real world scenario. So we're going to introduce another player to the board here. So we have the Bermuda High. Now we're going to introduce an upper trough. And you see this a lot. And usually with the upper trough, you have a surface cold front. I'm not going to show you the cold front, but if the cold front, we'll say it's right about here. So there's the high, it's steering the system towards the United States. The trough is dropping its way from north to south. And in this case, that trough, there's a certain point in time of when the system will basically be influenced by the trough. I don't know if it's like 300 or 500 miles away. I don't know the exact number, but you can clearly see a change in direction with the tropical system when the trough starts to play a part. So that system was headed for the United States, but fortunately this trough and also this cold front that you don't see is going to keep the United States safe in this case, and it'll make its way back out to sea. Now here's another scenario where the trough is really deep. The cold front's probably through Florida, and of course we have the Bermuda High. What's going to happen with this case is it's going to keep that system well to the south and push it into Central America, Mexico, the Yucatan, and other areas, potentially into Belize or something like that. Here's the scenario that we just dealt with. This was with Aaron. We had a upper level high pressure here, the Bermuda High here, then we had a surface high here or upper level high here. So you had this wall that tried to develop, but instead of the storm staying to the south, the storm found a weakness in those high pressures, and therefore it made its way right through that weakness part of that highway. Again, this is not real world exactly. Usually you've got lots of players on the board. That's what makes it more difficult for meteorologists to figure out exactly where a storm is going to track, and it gets more difficult the farther that you go out in time. So here's something that looks more realistic. You got high pressure, you got your subtropical high, your Bermuda high, then you got another high over in the Gulf, and then you got this trough dipping its way down, and maybe you have a tropical system here trying to develop off the coast of North Carolina, South Carolina. So all those factors play a major part in exactly how this storm is going to act. And it's very difficult because these are all moving pieces. They're not stationary. They're all moving around. So with time, of course, the numerical weather models are not going to get this exactly right. That's why you cannot forecast a hurricane 10 to 15 days out. I know there's a lot of stuff on social media, and it shows a model, and one day it will show a hurricane making landfall in Louisiana. And then 12 hours later, it'll show the hurricane making landfall in South Carolina. And then 12 hours later, there may not be a hurricane. So you have to make sure that you're getting trusted information, because social media, a lot of these places, they just want to scare you. They get that information from any public site. You can get that information of weather models for any site. You don't have to pay for it. There are some subscriptions out there for more technical stuff, but they throw these maps out there and they don't really have any explanations. It just shows a big hurricane hitting one of the Gulf states or the East Coast, and it's 10 to 15 days away. They're just making money off of your fear. And that's just wrong, but that's just the day and age that we live in now. They're not held accountable for that misconduct, I would say. But anyway, I'm done with my rant right now. So let's try to figure out exactly where this is going to go. And this is just a scenario, but just to give you an idea, you know, there's the future. So the hurricane is off the coast of Georgia, South Carolina, and there's still a lot of questions on exactly where it's going to go. If you remember, Sandy was supposed to go out to sea, but here's what happened. There was a trough that actually picked up Sandy and pulled it back to the west. So it was kind of like doing one of those tracks. So even though we're this close, sometimes the answer is still not clear on exactly what happens when a hurricane is only 1 or 2 days away. We're getting better and better with the track of the system that has been proven by the National Hurricane Center statistics. But sometimes when you have too many players on the board, it makes things a lot more congested and complicated to forecast for. Okay, next here on Weatherwise, we're going to talk about when a hurricane makes landfall, why there's such a difference in, say, 50 miles from the center of the storm versus 20 miles from the center of the storm, and what side of the hurricane you're on. You've heard of the dirty side before. We'll explain exactly what that is next. You may have heard that somebody has lived through a certain hurricane. Maybe they made it through Andrew, or maybe they made it through Katrina. But it just depends on exactly where they were located with perspective of that hurricane, because a hurricane, the effects are not the same across the board. You can break a hurricane into 4 sections, and we can take this full. You have the left front, the left rear, the right rear, and the right front. The worst place to be in a hurricane is going to be the right front quadrant. And the reason behind it is because the forward motion of that hurricane enhances the storm development, enhances other factors that can make the right front part of the hurricane the most dangerous part of the hurricane. Meanwhile, the left front, not to say you're not going to get slammed with terrible weather, especially the closer that you are to the eye wall, but as this system makes its way towards landfall, there are big differences in if you are 50 miles west of the eye wall versus 20 miles east of the eye wall. So there you see the left front, the winds are certainly not as bad as the winds in the right front quadrant. The storm surge, the flooding, the left rear, it's even a little bit lower because this part of the system is working against that forward momentum of the storm. So we're going to go to the next graphic now, and we're just going to take a scenario. This is kind of similar to what happened with Hurricane Michael as it made its way very close to Panama City Beach. Panama City Beach certainly got punched pretty hard, but it was Mexico City that felt the full brunt of this system. Meanwhile, Destin, which is right about here, versus Panama City, it's 75 miles away to the west, didn't really see much at all. Some rain, yes, some wind, but they were spared. So somebody in Destin that said, hey, I made it through Hurricane Michael, they didn't go through the same event that Panama City Beach went through, that Mexico City Beach went through, and then even folks off to the east had worse weather versus what Destin and Pensacola had. So the red arrow, that is the direction of where this storm is. Now we're going to break things down looking at the storm surge. The worst surge is going to be the northeastern section of this system, and then also the eastern part of the system. So they were likely expecting a nasty storm surge all along the west coast of Florida, through the Big Bend area, and then, of course, into Panama City Beach and Mexico City Beach, where houses were washed away by the storm surge alone. Meanwhile, on the opposite side, because you think about what's happening, you've got some really strong winds here just pulling up all that water and pushing all that water up into those coves and even into the rivers in this part of Florida. But the other side, the winds are coming from the other direction, so it's pushing the water out. And we saw that with around Tampa Bay with Hurricane Milton just last year. The water was pushed way out because they were on the opposite side at first with the strongest winds pushing all the water back out to sea. This is just a scenario of what the winds could be. So there you see tropical storm force winds, 39 to 74 miles per hour, taking up a large part of pretty much all the Florida Panhandle, but even part of the Florida Peninsula. The worst winds, usually around a hurricane, they don't extend very far out. A lot of times, every hurricane's different. The sizes make a difference in how far those hurricane force winds stretch out. But a lot of times, hurricane force winds are within 25 miles of the eye. Sometimes they're maybe 40 miles out from the eye. And then the tropical storm force winds, they can go out 100, 150, even 200 miles away from the eye. So the worst winds, Panama City Beach, Mexico City Beach, but then you drive off to the west and those winds really start to trend down. And along with that, the impacts also were much less in western parts of Florida. So there's your low pressure, lots of moisture, heavy rain, all this moisture is going to be pumped up into Georgia, South Carolina, North Carolina. But on this side, you've got drier air making its way into Mississippi and Louisiana. So if we were making a forecast, yes, the hurricane is not that far away, but most likely there's going to be some breaks of the sun throughout the day. Louisiana, Mississippi, even into western areas of Alabama, even western parts of the panhandle of Florida could see some sunshine. And then with that unstable atmosphere, storms would bubble up and we'd see some bands of showers and storms develop in that part of the country. But by far the worst weather would be Florida and into Georgia and the Carolinas. Along with that, because as the storm makes its way up the coast, you think about the winds, okay? You had those very strong winds at the surface, and then right above the surface, about 5,000 feet. What happens here, as those winds encounter land, those start to slow up. That friction starts to slow those winds up enough to produce wind shear. And when you have wind shear in place, that's when your tornado threat goes up. So, of course, within that northeastern quadrant and also the southeastern quadrant, you're going to have that potential of tornadoes. So you would have bands of storms develop. We've seen that here a lot in Arkansas. Daytime heating, those storms fire up. If we're on the eastern side of a dying system, you have tornadoes. Meanwhile, this side, Alabama, Mississippi, Louisiana, could be a pretty nice day, just with a little bit of a breeze. And another thing, when you have low pressure that continues to push its way up, it can bring in really dry air. And even some almost record cold temperatures can be on the backside of the system if things work out perfectly. So finally, we're going to take a look at one scenario here in Arkansas, since we're located in Arkansas. And I think this was from a few years ago. I think it was like Hurricane Laura is what we were trying to figure out. So this is the breakdown of what it would be like here in Arkansas if we had a system, a hurricane that was coming up and of course unraveling into a tropical storm. If the track of that system, the center of the system, was staying outside of Arkansas and into Mississippi and Tennessee, by far the worst impacts would be for those areas. That's where the tornado threat would be. That's where really the gusty winds would be. But let's change things up. Let's say the track of the system is now expected to be over parts of central Arkansas. So southeast Arkansas would get all the heavy rain, certainly a tornado threat extending as far as Pine Bluff and also even Little Rock, but also northeast Arkansas. Meanwhile, west Arkansas, low impacts. There'll probably be some winds here, maybe a few showers, probably some sunshine in this part of the state. Meanwhile, there's probably a lot of clouds and maybe some breaks of sun, but that just make the atmosphere more unstable in this part of the state. And then look at this scenario. We even push the track farther to the west, say Texas and into southeast Oklahoma, then the entire state has the potential of heavy rain and also not only gusty winds, but the tornado threat is also there. And that was certainly the case. Maybe this was with Hurricane Beryl, if I'm remembering now. So because we had a lot of tornadoes with Hurricane Beryl from that system. So that is a very thorough, in-depth look at some stuff. Once again, this is part 3 of talking about tropical weather. If you missed any other parts, you can find them on all the other episodes of Weatherwise, because we have part 1 and part 2. I think we're going to be done with tropical weather after this little break. We'll flip over to something else coming up here in Weatherwise. Thank you for tuning in as always. And if you have an idea you want me to talk about, feel free to email me at nscott@thv11.com. Have a great afternoon, and I'll see you soon.